evaluate the integral from 0 to 3, then integral from negative root 9 minus x squared to positive root 9 minus x squared into x cubed plus x y squared dy dx. Now, for us to be able to get the integral of this expression, it will be easier for us to convert this one into polar form before we can get the integral. Now, but before we change it to polar form, sometimes also good to know the region they are talking about. For example, for x, they are from 0 to 3, so we can say that x is greater or equal to 3. X is greater or equal to 0 and x is less or equal to 3. This is the region. And for y, this is the region minus the root of 9 minus x squared, that y positive root 9 minus x squared. Now this is the region. Now for x, if this is the xy plane, of course we know that on this side x, y, this is the positive side of x value, so x, this is the point of origin. So if this is 3, so but then x is from here up to that point, but then we need to get the value of y. Now from here we have y greater or equal to the root of 9 minus x squared. So from here you can say y equals to the root of 9 minus x squared. So we square both sides of this equation. We have y squared equals to 9 minus x squared. So x squared closer to this side, it will be y squared plus x squared equals to 9. Now you can see that this one is the equation of a circle. The equation of a circle is always given by x squared plus y squared is equals to r squared. So from this equation of the circle, we can get the radius. So if this is 9, then it means that radius equals to 3. Radius equals to 3. So when you compare this and this, you realize that this is the upper part of the circle, this is the lower part of the circle. So if r is equals to 3, so it's on this side. This is the positive part of y, so this will be 3, and then this one will be this side minus 3. So this is the circle. But which is the region? So if this is x 3 and y, we are integrating y from negative 3 to positive 3. Therefore, this is the required region. That is the required region. Now, after getting the required region, therefore we need to change all this into polar form. For the polar form, this is very important. For the polar form, you can use this. So this is y, this is x, this is the angle, this is r. Now from here, can apply SOHCAHTOA. Sine theta. The sine of the angle is given by opposite over hypotenuse. Opposite here is y, hypotenuse is r. So when you multiply both sides by r, you realize that y equals to r sine theta. Then cos theta equals to the cosine of the angle is given by adjacent over hypotenuse. Adjacent is x, hypotenuse is r. So this equals to adjacent over hypotenuse. Therefore, we are saying that x equals to cos theta. Again, applying the Pythagoras theorem, we know x squared plus y squared is equals to r squared. X squared plus y squared is equals to r squared. So these are very important information when we want to convert this into polar form. And again, we need to know that dx dy is given by r dr d theta. So from here, you realize that now this equation, we are integrating from this up to this. So in terms of the, remember this is the angle, so this is negative pi over 2, this is positive pi over 2. So the equation now becomes, this equation now will become the integral from 0 to 3, because remember r is now 3, which is the radius. Then r is 3, then this one changes. The integral from this, which is now negative pi to positive pi. Then here x, so we can factorize out x here. We factorize out so that we have x into x squared plus y squared dy dx. Now from here, you realize that this the integral from negative pi to 2 pi over 2. So this is x, but what is x? X is this cos x equals to r. This is r cos theta. So here we have r cos theta. So x squared plus y squared, this is r squared. Then of course dy dx. So this is r dr d theta. So this equals the integral of 0 from 0 to 3, the integral of negative pi all over 2 positive pi all over 2 r times r squared times r. We have r raised to 4 cos theta dr d theta. So this equals to, now we have dr d theta. So we can start with the dr. So this will be the integral of, we can interchange this, negative pi all over 2 pi all over 2, the integral of r raised to 4 cos theta dr d theta, so that we start with the innermost. So this will be equal to this is the integral of negative pi all over 2 pi all over 2. So when we integrate with respect to r, this will be r raised to 5 all over 5 cos theta, then 3 0, then d theta, like that. So where there is r, we put it there 3. This equals to minus pi all over 2, pi all over 2. Then we have, so it will be 3 raised to 5 all over 5 cos theta. So when we put that, it will be 0, so we remain with that. Then d theta, like that. So 3 raised to 3, 3 raised to 5, 3 raised to 5, 243. So here we have the integral from negative pi all over 2 to positive pi all over 2. Then we have 243 all over 5 cos theta, then d theta, then d theta. We can take 243 all over 5 outside, 243 all over 5 into the integral from negative pi to over 2 to positive pi all over 2, then cos theta, like that. So when you integrate cos theta, so this will be equal to 243 all over 5. It will be minus sine theta, then pi all over 2 negative pi all over 2. So this equals to 243 all over 5. And we now substitute, it will be minus sine now pi over 2, then minus not be minus sine negative pi over 2. This equals to, so pi over 2 is the same as 90, so we have minus sine 90 minus sine negative 90. Now we have met, when you integrate cos theta, you get sine theta, not negative, you get sine theta. So this sine theta, so this will be sine 90 and then minus sine negative 90 is equals to 2. So 243 all over 5 times 2, which equals to times 243 over 5. So this equals to 486 all over 5. Thank you for watching my video.